this lesson, we're starting with circuit analysis, but let's revise what you learned in the last video first.
En el vídeo anterior vimos las tres magnitudes básicas de la electricidad. La intensidad de corriente eléctrica, a la que a menudo nos referiremos simplemente como intensidad, el voltaje y la resistencia con sus símbolos y unidades. Muy importante recordar esto. Vamos con la ley de Ohm. Una definición sencilla, y no hay que olvidar que lo que dice la ley de Ohm es que a través de un circuito, una resistencia, un conductor, va a circular una mayor intensidad de corriente cuanto mayor sea el voltaje aplicado. Por el contrario, cuanto mayor sea la resistencia, menor va a ser esa corriente. Este concepto matemáticamente se expresa con esta fórmula tan sencilla. Hay gente que este triangulito le viene muy bien, podéis usarlo si queréis. Y creo que es importante también añadir un ejemplo de uso de la ley de Ohm, como este de aquí, en el que se calcula la intensidad de corriente. Y por último, os propuse una pequeña actividad para resolver que consistía en calcular el voltaje en el primer caso, ahí está, y calcular la resistencia en el segundo caso. Por favor, nunca olvidéis poner las unidades cuando calculéis algo muy importante. Y vamos por fin a la sección de análisis de circuitos, que es la más divertida. Ya veréis.
Circuit analysis is about finding the unknown currents and voltages in a circuit.
The best way to understand how circuits work is learning how to analyze them. And the first step is to learn about equivalent resistance. Let's do this.
Finding the equivalent resistance of a group of resistors is a very useful strategy when analyzing circuits. We will calculate the value of one resistor that will act like the initial group of resistors.
We can find resistors connected in series or in parallel. If they are connected in series, it's really simple. To calculate the equivalent resistance, you only have to add them up. That simple. When resistors are connected in parallel, it's not that simple, but it is still easy. This is the formula to calculate the equivalent resistance when resistors are connected in parallel. It can get really messy when you are trying to calculate the equivalent resistance of more than two resistors. So instead, I encourage you to use this other one. This formula is the same as the previous one, but just for groups of two resistors. So be careful with that.
Let's try and reduce the following networks of resistors to one single equivalent resistor.
So what we are trying to calculate here is the equivalent resistance to these three resistors here. And we need to find the resistor that will behave like the three of them connected in series. As they are connected in series, the equivalent resistance is just adding them up. That is 5 plus 3 plus 2, that's 10 ohms. Very easy. Now, let's take a look at the second circuit, well, the second resistor network, which is only 2. This is even easier. For these two, again, what we are trying to calculate is one resistor that is equivalent to these two, as they are in series too. The equivalent resistance is just adding up. This is 50 plus 75, that's 125 ohms. Now let's take a look at the third one, which is in parallel. When they are in parallel, you cannot just add them. Again, we are trying to find the same thing. We need to find the equivalent resistor to these two in parallel. But to calculate this, you cannot just add 10 and 5. You have to use this formula here, which is for groups of two resistors in parallel. Okay, so now I will use the data. It is 10 multiplied by 5, 10 plus 5, that is 50 divided by 15, which will be something like 3.3 period ohms. Let's take a look at this one now. This one is in parallel and has 3 resistors. Okay, this one is easy too, but what you cannot do is to use the previous formula like this. The equivalent resistance of these 3 is not, you cannot calculate it like this. This is very important for you to remember. This is completely wrong. Please don't do this ever. No, no, no. Okay? You cannot use that formula. That is not correct. So what do we do? Well, in this case, what we are going to do is the following thing. We want to calculate first the equivalent resistance of 2 of them, 2 resistors first. And that will get us, okay, I'm going to redraw this. We will calculate the equivalent resistors of these 2 first. And still, we still have the other one. This is R3, which is 5 ohms. And to calculate this one, I'm going to do it here. I have to use the previous formula. So it will be 10 multiplied by 10 divided by 10 plus 10. That is going to be 5 ohms. So now I know that this resistance is 5 ohms here. And now I have to calculate again the equivalent of these 2 in parallel, because my goal here is to find one only resistor that is equivalent to everything else. This equivalent resistor is the parallel now of these 5 ohms and this other 5 ohms. Again, we need to use this same formula, and it will be 5 times 5, 5 plus 5, which is 2.5. So this equivalent resistor is 2.5 ohms. That's it. I bet you can't get enough of this, so here you have more for you to practice. Bueno, pues ahora, como siempre, lo que te propongo es que continúes con tus apuntes. Hemos aprendido cómo calcular la resistencia equivalente cuando están conectadas en serie y en paralelo, y eso es lo que deberías anotar en tu cuaderno. Después, te recomiendo que resuelvas todos los ejemplos de resistencia equivalente que has visto. A, B, C, D, E, F, G y H. ¡Ánimo!